Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 6C, Percents. We're going to go over the questions at the end of that subchapter in the Barron's SAT Guide, whether you have the regular SAT, Barron's SAT, or the Premium Study Guide. Doesn't matter, it's the 30th edition of Barron's SAT. So, question 1 on page 477. Charlie bought a $60 radio on sale at 5% off. How much did he pay, including a 5% sales tax? This question is trickier than it looks. The answer is not D, which would be $60. First, we have to take 5% off $60. With a calculator, all you need to do is this. You just go 60 minus 5%. See, it tells you 5% is 3 right there. Boom, becomes 57. So if it's on a calculator section, this is super easy. But let's assume it's not. Let's assume the problem is in a non-calculator section. It's easy to calculate 10% of a number. You just move the decimal point or divide by 10, so you get $6. This is also a good way to figure out a tip, so you just figure out 10%. And then since 3 is 1/2 of 6, so you just take the 10% and take half and you get 5. The 5% of $60 is $3. If you're figuring out a tip, you can just take the 10%, add it to the 5%, voila, you've got a 15% tip, which is sufficient. So, anyway, 5% of $60 is $3, so the price before sales tax is $60 minus $3, which is $57. So now we have to calculate 5% of $57. 10% of $57 is $570, so 5% is $285. So easy way to do this without touching your calculator is we know that $250 is half of $5. So you can say, all right, we'll divide the $5 by 2, and then half of 70 cents is 35 cents. So 250 plus 35 cents is 285. So then we add $57 plus 285 to get $59.85, choice C. That's a really typical SAT question where you take a percentage off and then you re-add it, such as when there's a sale but there's a sales tax. It's not the same. If you're going to add 5% to the smaller number, that's going to be less than what taking 5% off gives you. In other words, notice that 60 minus 5% is $57, but when you re-add the 5% to the $57, it doesn't take you back to $60. It only takes you to $59.85. That's always going to work that way. When you add the same percentage to the lower number, it doesn't bring you back to the original high number. All right, enough on that. Question 2, page 477. If A is a positive number, 400% of A is what percentage of 400A? Well, all right, we know 100% of something is the whole thing or just one thing. So any whole multiple of 100% is just more than one of that thing. So 400% of something would be 4 of those things. So 400% of one apple would be 4 apples. Thus, 400% of A is just 4 times A, or 4A. So now that we know the 400% of A is 4A, to find the percentage 4A is of 400A, we just divide 4A by 400A and multiply by 100%. So we can see that the 4's cancel out, the 4 in 4A and the 4 in 400A. So you end up times 100%, so that just becomes 1 over 100, because the A's also cancel out. So it just becomes 1 over 100 times 100%, which is 1%, which is choice B. Question 3, page 477. What percent of 200 is C? Now this is a confusing question. I had to look at that for a while to figure out what they were getting at. I looked at the answer choices like, oh, okay. So once you understand what they're asking, just set up a proportion like C over 200, because C is going to be some proportion. It's going to be some part of 200. And we know that's going to be equal to X over 100, which by definition is X percent. So X is going to be the percentage that we're trying to find. So then you just cross multiply. So we get 100C is equal to 200X, because we go 100C like this, 200X like this. And so 100C over 200 just ends up with X is equal to C over 2. That's choice A. Hopefully you understood that. If you don't, you can always contact me. Question 4, page 477. At Harry's Discount Hardware, everything is sold for 20% less than the price marked. If Harry buys toolkits for $80, what price should he mark them if he wants to make a 20% profit on his cost? Be careful. It's easy enough to compute 20% and add it to the $80 wholesale cost. It's just 2 times 10% of 80. So from what we did before, we know 10% of 80 is just $8. So 2 times $8 is $16. So the price for which he should sell them is $80 plus $16, which is $96. Hey, that's answer A. We're done. No, we're not done. That's the sucker punch answer. That's why they put it in the A section, whatever, in the A spot, because they know enough people will look at it and go, oh, look, 96. There it goes. Anyway, excuse me, got to clear my throat a little bit here. Anyway, the question asked what should be marked, and the price for which Harry sells them is 20% less than the marked price. So we have to figure that out. We also know from before that you adding 20% to the $96 won't give us the price that we would reduce by 20% to get 96. It's going to be bigger than that. So we can't just add 20% to $96, which would be 2 times $9.60, which would be $19.20, which would be $115.60. That's not even one of the answer choices here, so we know that's not the right answer, and hopefully you already knew that that wouldn't be the right answer. Okay, so you can't just add the 20% to the $96 price Harry must collect. You do have to set up an equation where $96 is equal to 0.8, 80%, times MP, where MP is the marked price. You can use whatever variable you want. I just figured MP works pretty well. So $96 is equal to 4/5 of MP, because 4/5 is equal to 0.8. Hopefully you know that. If you don't, please watch the video on decimals and fractions. Please also read that in the Barron's book, or find something online about decimals and fractions. But I digress. Okay, or 5/4 of 96, because we're just going to divide by 4/5. That's the same as multiplying by 5/4 of $96 is equal to MP. Since 96 is equal to 4 times 24, then 5/4 times 96 is going to be 5 times 24, because the 4's cancel out. So that's equal to $120. It's important to know how to factor, because that'll help you a lot on the non-calculator sections. And a lot of times, if you're good at factoring these things out, even on the calculator section, you can do it faster this way than you can do it on your calculator, because you have to reach for your calculator, turn it on. Anyway, that's choice C. Question 5, page 477. 9 is 1/3 of a percent of what number? So let's set up an equation. 9 is equal to 1/3, and we know 1% is just another way of saying 1/100th. So it's 1/3 times 1/100th of n, where n is our number we're trying to find. So that's equal to 1/300th of n. And n is the number, in case you couldn't figure that out, in case you didn't get that from what I just said. Anyway, so 9 is equal to 1/300 times n. So we multiply both sides by 300. So then we're just going to get n is equal to 9 times 300, which is 2700, which is choice D. And in case you didn't get that, 1/100 is 1%, so 1/3 of 1% is 1/300. All right, pretty sure you understand that. If you don't, watch it again. If you still don't understand it, feel free to contact me. Question 6, page 477. Got a little college fund going on here. Mr. Howard was planning on depositing a certain amount of money each month into a college fund for his children. He then decided not to make any contributions during June and July. To make the same annual contribution that he had originally planned, by what percent should he increase his monthly deposits? Oops, it says B increase here. Sorry about that. Should be he increase. Since he and B are both numbers, I guess the spell check, they're not both numbers, both words that the spell check would recognize. Oh well. Okay, don't like it, sue me. So, what we're going to do here is, first I'm going to explain, he decided not to contribute in June and July before he started the college fund, because the problem becomes much harder if you assume that he donated all the way through May, and then all of a sudden said, oh, wait a minute, I can't give in June and July. Then he'd have to he'd have to adjust the payments made in August, September, November, and December to increase that, and that makes it a harder problem. So, now that we know the problem is not as hard as we thought it would be, there's an easy way to do this. Why don't we just set the amount of the monthly contributions to $100? So the yearly contribution would be $1,200, because 12 times 100. Since Mr. Howard then decided not to contribute for 2 months, he would have to make up the rest in the 10 months where he did contribute. So it's easy enough to take the $1,200 and we just divide that by 10 months. So you get $1,200 over 10 months, which is $120 per month. So the percent change is going to be 120, that's the new value, minus $100, that's the original value, over $100, and that's times 100%, which is equal to 20%, which is choice B. Question 7, page 477. During his second week on the job, Jason earned $110. This represented a 25% increase over his earnings of the previous week. How much did he earn during his first week of work? Well, the percent change is going to be new minus old over old, same as we did on the previous problem. So it's a new value minus the old value over the old value times 100%. So it's going to be $110 versus first week, whatever that was, the amount he earned the first week, over the first week times 100%, and we know it's equal to 25%, so we just have to work this backwards and solve for the first week. So solving for first week, we get 25% divided by 100% times first week equals $110 minus first week. So all right, we know 25 over 100, and the percents cancel out. We get 1/4 of first week is equal to 100 minus first week. So let's add first week to each side. So we get 5/4 of first week is equal to $110. So first week is equal to $110 times 4/5, which is equal to 22 times 5. 100 is 22 times 5. Really, factoring, it's important to learn, is 4/5 times 4/5 equals 22 times 4, which is 88. So that's choice C. Again, 110 times 4/5. Okay, we know that that's going to be 22 times 5. Why? Because it's 11 times 10. Anyway, so we just cancel the 5s out. 4 times 22 is equal to $88, which is choice C. Okay, hopefully that makes sense to you. You know, $22 times 5 times 4/5, so the 5s cancel out, so it becomes 22 times 4. All right, think I've explained that one to death. Anyway, choice C, $88. Have any trouble, contact me. Question 8, page 477. What is 10% of 20% of 30%? So notice all the answer choices in the book are in percents. So you don't have to do the math in percentages, though. I would just go 0.1, 10% times 0.2, 20% times 0.3, 30% times $100. So that's 0.6%, which is choice B. Because if you do this on your calculator, we can do it. 0.1 times 0.2 times 0.3. So we get 0.006, but we have to multiply it by 100 to get the percentage, right? So that's 0.6%. Is that awesome? Yes, that is super awesome. Oh. Question 9, page 477. If 1 micron equals 10,000 angstroms, then 100 angstroms is equal to what percent of 10 microns? Well, all right, so we know that 100 angstroms is 1/100th of 10,000 angstroms. How do we know that? Well, because we know that 1 micron equals 10,000 angstroms. So then 100 angstroms, okay, would be what percent of 10 microns? Okay, so we know we just take 100 over 10,000, and that should give us 0.01, 1%. So we know that 100 angstroms is 1% of 1 micron. As it says here, 100 angstroms is 1/100th of 10,000 angstroms, and 10,000 angstroms is 1 micron. It says micron here. Oops, sorry about that. Anyway, 100 angstroms is 1% of 1 micron. So it follows that since 100 angstroms is 1% of 1 micron, and 1 micron would obviously be 1/10 or 10% of 10 microns, we're just going to divide by 10. And we get 0.001. So that's 1% times 0.1, or 10% equals 0.1%. And we haven't multiplied by 100 to get the percentage yet, and sure enough, we get 0.1 when we figure out the percentage, which is choice C. All right. Question 10, page 478. On a test consisting of 80 questions, Marie answered 75% of the first 60 questions correctly. What percent of the other 20 questions did she need to answer her correctly for her grade on the entire exam to be 80%? So first, 75% of 60 is 3/4 of 60. Hopefully you know 75%. And 3/4 the same thing. You can think 3/4, the coins, which are 25 cents, is 75 cents. So anyway, 75% is 3/4, so 3/4 of 60 is 45. You can also think of 60 minutes in an hour. 45 minutes is 3/4 of an hour. If you're lucky enough that this would actually be on the calculator section, you can just go, of course, 60 times 75%, boom, which is 45. Okay. Second, 80% of 80 questions. Well, again, we can go 80 times 80%, which is 64. The way to do it without a calculator, know that 10% of 80 is 8. Obviously, 80% is going to be 8 times 10%, so that's going to be 8 times 8, which is 64. So Marie must answer 64 questions correctly to get an 80%. So she needs 64 minus 45. Hopefully you can do this by hand, but if you have a calculator, you might as well use your calculator to avoid stupid arithmetic mistakes. That's 19. Well, okay, 19, and we know there are 20 left because she did 60. So that means 19 divided by 20 out of the remaining. That's 0.95, or 95%. You can multiply it by 100 if you're really insecure about it. So there's your 95. That's 95%. You can also multiply 19 over times, I'll try that again. You can multiply 19 over 20 times 5 over 5 to get 95 over 100, or 95%, which is choice C. 1 over 20 is equal to 5%. That's also worth knowing. So, you can go 1 over 20 is 5%. All right. On to the next one. Question 11, page 478. A jar contains 2,000 marbles. If 61.5% of them are red, 27.2% of them are white, and 10% are blue, how many are neither red, white, nor blue? All right, let's assume it's on the calculator section. Doesn't have to be. It's easy enough math to do, but if it is on the calculator section, you can go 61.5 plus 27.2, okay, plus 10. All right, so that's 98.7%. All right, so then all we can do is just make that negative and add it to 100%. And then we get 1.3% of the 2,000 marbles are something other than red, white, or blue. So we can divide this by 100 to get the decimals. That's 0.013. And then we just multiply that by 2,000, and you get 26. Now, this would not be that hard to do if you couldn't do it on the calculator section. You just have to multiply 2,000 times 1.3, or sorry, times 0.013. Well, wouldn't be that hard, but hopefully it'll be on the calculator section. But you could just know, okay, 13 times 2 is 26. And then you just go, okay, how many things do I have to do? Well, I'd go probably write it out as 0.013, and then I'd say, okay, well, I want to move this over 3, so then I'd say okay, 1, 2, 3. So yeah, this would be in the tens. Well, you just multiply it by 1,000, right? So that becomes 13 times 2, which is 26. All right, so you can do it with a calculator. You could easily do it by hand. It's not that hard either way. Okay. Question 12, page 478. If 50 students applied for an internship and 8 of them were accepted, what percentage of them were rejected? Well, if 8 were accepted, 42 were rejected, we can set up a proportion. So you have 42 over 50 equals x over 100. Hopefully you should see that you could multiply 50 times 2 to get 100, and to keep this proportion you have to multiply 42 by the same number to get x. So we can just multiply by 100, so we'll go 42 times 100 over 50, 100 over 50 is 2, 42 times 2 is going to be equal to 84%, where x is the percent, 42 is a 50, so grid in 84. Question 13, page 478. There are twice as many girls as boys in an English class. If 30% of the girls and 45% of the boys have already handed in their book reports, what percentage of the students have not yet handed in their book reports? Okay, let's say there are 200 girls and 100 boys in the class. The numbers don't have to be realistic. I mean, in a class where you're writing book reports, I assume it's something like this where you're in elementary school, maybe in junior high, middle school, whatever you call it in your school district, but we don't care. Let's say there's 200 girls and 100 boys in the class. So we're going to have 30% of the 200 girls, that would be 60 girls, have handed in their reports. So in case you don't believe me, here we can check it. Just go, all right, 30%, so 0.3 times 200, boom, 60. And then 45% of the 100 boys, you should be able to figure that out without touching a calculator. Just know that 45% of 100 is 45. So that's why I picked hundreds to do this. So okay, so we have 45 plus 60, 45 boys and 60 girls. That's 105 who did it. So remember, there's 300 total, 200 girls, 100 boys. So we're just going to make this negative, add it to 300, and boom, we get 195. Or you just take 300 minus 105. Doesn't matter. I don't care how you do it. And boom, 195. So then 195 students have not handed in their reports. But are we done yet? No, because we have to find the percentage. So you could get sucker punched into going, oh, 195, there's enough room, I'll grid that in. You have to go 195 over 300. Boom, 0.65, 65%. Also, hopefully you'll remember that these numbers are numbers you made up. They didn't give them to you in the problem, so you're going to have to figure out the percentage yourself. Anyway, let's move. Question 14, page 478. During a sale, a clerk was putting a new price tag on each item. On one radio, he accidentally increased the price by 15% instead of lowering the price by 15%. As a result, the price on the tag was $45 too high. What was the original price in dollars of the radio? So let OP equal the original price of the radio. So OP times 1 plus 0.15, that's the way that you would express a 15% increase, because OP times 1 is obviously itself, it's just OP, and the 0.15 would be the 15% increase. It's equal to OP times 1 minus 0.15, which would be a 15% decrease, plus $45, so OP is equal to OP times 1.15 is equal to OP times 0.85 plus $45. So 0.3 or 30% of OP is equal to 45, so that means 3/10 of OP is equal to $45. So 10 over 3 times 45 is equal to 10 over 3 times 3 times 15, so the 3's cancel out, so we get 10 times $15 is equal to $150, so just grid in 150. Question 15, page 478. If a person has an income of $100,000, what percent of his income does he pay in federal income tax if the tax rate is as given below? 15% of the first $30,000 of income, 28% of the next $30,000 of income, and 31% of all income in excess of $60,000. The tax on the first $30,000 is 15% of $30,000. That should be easy. 10% of $30,000 is $3,000. 5% would be half of $3,000, so that'd just be $3,000 plus $1,500, which is $4,500. Or if you're on the calculator section, then it's easy enough. You just go 30,000 times 15%, boom, $4,500. Okay, 28% of $30,000. Okay, let's just use the calculator. So you're just going to go $30,000 times 28%. Boom. So that's $8,400. Okay, so then what we have next is we have $40,000 that we have left over because these first two $30,000 increments only cover $60,000. 100,000 minus 60,000 is 40,000. 100,000 minus 60,000. So that's 31% of $40,000. So 31%. Oops, 31. Okay, I guess it doesn't like it when you do it that way. So we'll just go $40,000 times 31% is 12,400. So then we'll add the 8,400 from before, and then we're going to add this 4,500. And we get 25,300. Since the income is 100,000, they're asking what percent of his income does he pay in federal income tax. We just divide by 100,000, and we get 0.253. You can either figure out that that's 25.3% or multiply it by 100 to get the percentage if you like. Either way, you end up with 25.3. So just grid in 25.3. And notice that since it's $100,000, that was a really convenient number to use with a percentage. So sometimes you do get a break on the SAT. All right. Question 16, page 479. The price of a can of soup has increased by 20%. How many cans of soup can be purchased for the amount of money that used to buy 300 cans? So let's assume the original price of the soup was $1 per can. Easy number to use. Then a 20% increase would just raise the price to $1.20 per can. So you would just go 1 plus 20%. Okay, so it's $1.20, just as I showed you. So we know that $300 used to buy 300 cans of soup, right? So you would just go $300 was used to buy 300 cans. So then that you just divide by 1.2, which is the new price, $1.20. Boom, you get $250. So hopefully you understand why I use $1 per can. It's really super easy because 300 times 1 is just 300. You just divide 300 by $1.20 per can, and voila, you get 250 cans. Just grid in 250. All right, let's move to the next one. Question 17, page 479. An art dealer bought a painting for $1,000 and later sold it for $10,000. By what percent did the value of the painting increase? So the percent increase or decrease is just going to be the new value minus the old value over the old value, as we've already done on a couple other problems here, times 100%. So we have $10,000 minus $1,000 over $1,000 times 100%, which is 9 times 100%, which is equal to 900%. So just grid in 900 and you're done. Question 18, page 479. Jar B has 20% more marbles than Jar A. What percentage of the marbles have to be moved from Jar B to Jar A in order that, I put sick in there, spelling is correct. They put in order that. I think I would put in order to, but I make enough typos on these, I can't really complain about their typos in the book. Anyway, that the number of marbles in each jar will be the same. So let's assume that jar A has 100 marbles. You could even draw a little drawing if you want of a little jar and 2 little jars. And so if jar A has 100 marbles, then jar B must have 120 marbles, 20% of 100. Hey, it's almost like I picked a really easy to use number, like 100 with a percentage. So we can easily see that 10 marbles would have to be removed from jar B for them to both have the same number of marbles. You take 10 out, put the 10 in jar A. Woo, jar A and jar B both have 110 marbles. So we just take 10 over 120. Boom, you get 0.833333, multiply by 100, and it's 8.33%. So that's easy enough, just grid in 8.33. And question 19, page 479. Wendy drew a square. She then erased it and drew a second square whose sides were 3 times the size of the first square. The area of the second square is k% greater than the area of the first square. What is k? Well, the area of a square is the side length squared. So you take the side here times the side, the area is equal to side squared. And so if you increase the side length by 3, then you have 3 times side, then the area is going to be equal to 9s squared. So it increases the area to 9 times the original area. If we assume the original square had side length 1, which we should, the original square's area was 1, and the new square has side length 3, and the new square's area is 9. So the percent change would be the new value, 9, minus the old value, 1, over the old value, 1, which is 8 over 1, which times 100%, which is 8 times 100%, which is 800%. So K is 800. Grid in 800. All right. Question 20. In a large jar full of jelly beans, 30% of them are red and 40% of the red jelly beans are cherry. If 25% of the non-cherry flavored red jelly beans are raspberry, what percentage of the jelly beans are either cherry or raspberry? So let's assume that there are 1,000 jelly beans in the jar. Since we're probably going to have fractions of a percent here because we're taking percentages of percentages, it's a good idea to use 1,000 instead of 100 or something like that. So okay, so if we take 30% of 1,000, we go 1,000 times 30%, boom. So that's 0.3, that's 300. So then we take 40% of that, so there's 300 red jelly beans. Take 40% of that to find the cherry, so we just go times 40%, boom. That's 120. So then 300 minus 120, we'll just make that negative and add it to 300, is 180. So there are 180, and they tell you that 25% of the non-cherry flavored red jelly beans are raspberry, so we're just going to multiply that times 25%. You could just multiply it by a quarter if you wanted, since 25% a quarter, and we get 45. So 1/4 of the 180 non-cherry red jelly beans are raspberry. Okay, so we have 45, and they just want to know what are cherry or raspberry, so you take 45 and you add it to the 120 cherry flavored, and that is 165. So we add 120 and 45 to get 165 jelly beans. We divide that by our 1,000 and we get 0.165, and we can multiply that by 100 to get the percentage. So that is 16.5%. Just grid in 16.5. So easy enough to do, almost as though it's a contrived SAT problem and one that I've done before, so I knew not to just use 100%. Okay, so here we go. For the best results, I do suggest you use the Barron's SAT 30th or 29th or even the 28th edition. As you should know by now, since we've gone through the whole thing, this video covers page 477 through, 449 anyway. Okay, obviously that's a mistake, so it's 477 through 479 in the 30th edition of the Barron's SAT, either the premium SAT guide or just the normal 30th edition of Barron's SAT. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT from 2016 in any event. It's the edition that was released for the 2016, in quotes, new SAT, so it might have come out in 2015. Anyway, don't use something earlier than the 28th edition. Not everything in the book is in these questions. Please do obtain that book, read the book. The older editions of this book can be had cheaply, if not for free, from used booksellers. Kids who've already taken the test in public libraries. They do sell old editions, or you can borrow the current edition. If you plan to use a library copy or a new edition, I suggest you start early. There's no worse feeling than needing a library book someone else has checked out, or trying to buy a review book that's sold out. And come on, you're not really going to be able to review in 2 or 3 days or whatever right before the test. Start early, it's a good idea. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? Well, it's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers. I think I'm up to about 766, something like that at the time of this recording. And if you have a copyright issue, you think I'm using information, copyrighted material that belongs to you, please contact me and we can work this out. I don't think I'm using anything that isn't fair use, but hey, if you feel differently, let me know. And for the same reason about the subscribers and watch time and anything else, you are not only welcome but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. If there's something you'd really like to see me cover, let me know. And if you found a mistake that I haven't already pointed out and tried to correct, let me know. If you have anything else to say, let me know. However, I do reserve the right to delete comments from and block those who specialize in destructive criticism. You know, trolls or things that are off topic, spammers, disturbed people, somebody who just needs to put something that really isn't related in my comment section. No, don't do that. If you need to contact me, please call me 415-623-4251 if you'd like to arrange for some private tutoring. I'd be more than happy to help. You can always text me on that number too, 415-623-4251. My email is john@johnlinnebaugh.com. My mail is 1859 Powell Street, number 109, San Francisco, California, 94133. Thanks for watching. And there's more information coming up here. Contact me, Facebook, Instagram, email, phone. My Facebook page is at www.facebook.com/Linnebaugh Tutoring. Instagram, https, www.instagram.com/john.linnebaugh.tutoring. Of course, these are for my business. My personal pages are different. Phone, 415-986-7355. Email, john@johnlinnebaugh.com. Website, www.johnlinnebaugh.com or johnlinnebaughtutoring.com. Both take you to the same website. And I have a locals.com page. You can find me, contact me, whatever, at testpreparation.locals.com. Hope this helps. Have a good day.